Welcome back. We're going to do the chain rule today. This is another huge result in calculus used all the time. Just to remind you before I guess we get into it, there's something called composition of functions. It can be written a few ways, but one way is this with that little circle. It's called f composed with g, and all it really means is that you are taking g and plugging it into f. It's called composition of functions. Often when this is done, people refer to this as the outside function and this guy to the inside function. Examples of compositions would be sine of x cubed. That's a function where the sine is the outside part and the x cubed is the inside part. Another example would be e to the t squared, where the outside part is the function e to the t, and the inside part is the function t squared. You're plugging t squared into e to the t. All right, the point of the chain rule is it tells us how to do derivatives of compositions of functions. So here is the statement. If you have two differentiable functions, f and g, then the derivative of their composition is f prime evaluated at g of x times g prime of x. You can also write the derivative using that other notation, namely f of g of x. If you want to know this guy's derivative, we'll write it this way. It'll be the same thing. F prime at g of x times g prime at x. So people have this mantra, they say, the derivative of the outside part evaluated at the inside part, that composition, it's the derivative of the outside, f prime. So you take the derivative and then plug in the inside times the derivative of the inside. Okay? So again, the derivative of f composed with g is the derivative of the outside, plug in the inside, and then multiply by the derivative of the inside. All right, let's do a couple examples here. So the first example is d by dx of the sine of x cubed. All right, you have to recognize this is a composition of functions where the outside part is the sine function and the inside part is the x cubed function. So the product rule says to do this derivative, you take the derivative of the outside. Now the derivative of the outside function is, derivative of sine is cosine, but I'm supposed to evaluate it at the inside. And then you multiply by the derivative of the inside. So that's 3x squared. Okay. So you have to change this x here to x cubed, so the answer is cosine of x cubed times 3x squared. Most people will put the 3x squared in front so that you don't need the parentheses. Okay. All right, next example. Let's do d by dt of e to the t squared. Okay. Here you have to recognize the outside function is e to the t, and the inside function is the function t squared. So the product rule says take the derivative of the outside function, that's just e to the t, but you have to evaluate it now. You have to plug in the inside part, which is t squared, and then you multiply by the derivative of the inside, so that's 2t. So what you get is e to the t squared times 2t. Yeah, people usually put the 2t first. It just looks prettier. All right, and one more example. Let's do d by dx of the square root of x to the fourth plus 1. It's helpful to think of this function as x to the fourth plus 1 and the 1/2 power. But anyway, you see here that the outside function is x to the 1/2, the square root, and the inside function is going to be the x to the fourth plus 1, because you're plugging the x to the fourth plus 1 into the square root function. So the derivative, by the product rule, you take the derivative of the outside function, so that's the derivative of x to the 1/2, so that's 1/2 x to the minus 1/2. And then I have to evaluate this at x to the fourth plus 1, namely plug that in for all my x's. Then I multiply by the derivative of the inside, so that's 4x cubed plus 0. All right. So here we get 1/2 x to the fourth plus 1 to the minus 1/2 power times 4x cubed. You simplify a bit, which seems natural. You get 2x cubed times 1 plus x to the fourth to the minus 1/2. You can leave it like that. Of course, that's fine. You could also change this to 2x cubed and move that negative down to the bottom. So 1 plus x to the fourth. There's rarely incentive to do that, but if you feel like it, there you go. All right, that's the chain rule.